Bonsoir à tous. Good morning, good evening, everyone. This is Jeroen van der Linden talking. Hope you can hear me. I'm very happy to introduce this second event for the Geneva Serverless meetup. This time it's on YouTube. If you have any issue with the sound or video, please just put a note in the chat. Hello, Gwenaël. Is that working well on your side? Okay, perfect. So thank you, everyone. Today I'm happy to have someone with me. For this second event, I'm happy to have Quentin, Michael, and Ben from Gamercraft. They will give a real return on experience from the field. So during the following hour or so, we will have a great feedback from this team at Gamercraft. And I'm very happy to have you guys this evening and to hear about your story. And very excited to know how you built this gaming platform with serverless technologies. So thank you very much for your time. And the floor is yours, Quentin.
Wonderful. Hello, everyone. I'm just going to share my screen right now and presentation. 2 seconds, and the full screen. Perfect. Yeah, so my name is Quentin Rosso. I am the CTO and co-founder of Gamercraft. Today, we have two team members, Michael and Michael Molisani and Ben Paul, who are both software engineers in our team. Yeah, so we'll be talking about basically how we use serverless to launch a tournament ecosystem in a fraction of the time that was, normally we would take to build a platform like this. First of all, I will explain what is Gamercraft, where do we come from, what do we do, introduce a bit our initial technology decision making, and how we went about choosing serverless as a main technology. Then Ben will provide a great overview on our architecture, more in depth, and then Mike will explain a couple of use cases, tools, and challenges and opportunities we faced using serverless. So first of all, Gamercraft is a company that was started officially a year ago, but we restarted the business at the early stage of COVID-19 back in March. So when COVID-19 hit, our previous company was hyper dependent on physical business in the gaming industry, so we had to shift everything. And it's in that mindset, it's important to understand, it's that mindset that we went into building everything. So first of all, how did we go about the idea and everything? So we interviewed over 1,000 gamers in a span of like 3-4 weeks about what is going on with, what are the issues with a competitive gaming experience right now. You might know that gaming is growing pretty fast every year. It's the largest entertainment industry, and we found out that a lot of gamers had major pain points related to 3 main things. Basically, like cheating, matchmaking, and obviously a more professional way of organizing tournaments. So first about cheating, you may know that there's a lot of cheating happening in games, both from automated sources such as bots and also from behavioral sources such as people playing in the place of someone else. And so that's a very frustrating experience, especially when you're trying to play in a tournament with high stakes, especially cash or money stakes. So that was one of the big issues we found. The second one was about matchmaking and skill matching. Within the gaming platform, a lot of tournaments are pretty well, people are pretty well matched on the same level. But when you're talking about third party tournaments run by third party on Fortnite, League of Legends, Call of Duty, etc., you're going to get a discrepancy and between the levels on the skill matching. So you end up you're a mid-level player, you end up playing against a high-level player, so creating a very high frustrating experience for the players. And finally, the last issue we found is people today are ready to increase the stakes when playing games, meaning that they're ready to basically gain cash the same way you play on a poker platform and make money out of it. They are seeing millions and millions of dollars going to professional gamers, and so now they want to experience the same thing. So that's where we come in, and I will talk a bit about our revenue model after, but our revenue model is about entry fees into tournaments, a monthly battle pass, a monthly subscription to tournaments. I will talk a bit more about it later on. But basically, what we came up with was an iOS Android app acting just as a companion to your gaming experience, which is happening on both your console, PC, mobile, doesn't matter, right? The point is, what's happening on our end is we organize the tournaments, we internalize the process of the tournaments on our platform. We help people creating teams so they can meet relevant individuals like them, and they can actually join tournaments, we organize the tournaments, and then they can win prizes, which in this case can be cash, gift cards, etc. More specifically, the way it works is a user will find a tournament, they will draft their team, they will win rounds, they will play games, and then they will win prizes. So pretty straightforward, very simple, but it comes down to also the way we integrate with the gaming platform. It will actually matter a lot in our serverless architecture. So important to understand that we integrate with League of Legends, for example, with their API, where we actually create a game code, right? So you can use that game code and input into your gaming client and retrieve any kind of data from that gaming client on our end. So the score of the game, any type of events within the game we can use to analyze both like potential cheating situations and game outcome. So now that's what we wanted to build, right? That was our initial idea. Of course, it changed over time, but our initial idea was how do we build that application, and how do we professionalize amateur esports in a fair and adjusted way for the players. So to backtrack a bit, in my past startups, in my past experiences, I always thought it was a better idea to actually start with like professional, like an agency or a company that knows the stuff more than we do, and of course for speed, bring contractors early in the project to build the MVP, and then building a sustainable founding team after that. So the partner we chose was Fiodo, and you might know them. They are pretty like they're big in France and the UK. They're also based in New York, and when we came to them, we were like, okay, let's build something together, and what technology do we need to choose? And that question came up, and my first thought was, okay, let's use Django or something like this. I used Django, Laravel, any type of frameworks before, and they said, well, why not going with serverless? Why not doing that? And I was like, okay, let's give me the arguments, and we make a decision. And so that was a pretty straightforward decision, actually, because the advantages were enormous. So first, of course, serverless already, everyone, so I won't go too much into that, but it means less painful scale-ups for us, less performance bottleneck when surging traffic, especially in our case where we have very high increase in traffic during tournaments, when tournaments are happening, and like of course smaller when there are no tournaments. So it helped adjust to the need. Finally, also we have fewer database scalability constraints. Our database obviously is serverless. We use DynamDB. There are pros and cons, obviously, but in this case, we don't have to worry about scalability. So serverless was, the key selling point with these ones. And of course, we're also getting other selling points. First, we're getting more computing power for lower cost. And I know in some cases it's the opposite, right? You may end up paying more for what you get out of serverless. It's better to create an EC2 instance and run something. It might cost less, but in our case, it actually does the opposite. It's actually lower cost in our case. So we also have more integration of AWS products. And in this case, there is also a con, which is you may be obviously way more reliant on AWS. Switching costs are definitely higher. But in our case, we didn't mind that because we are seeing AWS as a long-term partner in our strategy. And we want to enjoy the benefits from their game tech, let's say technologies or any other technologies they have. Finally, it's more reliable. And obviously, we don't have to manage the server aspect of it. Our developers, our team just start building, we go straight into building features and pushing them. We don't have to worry about the rest. So talking about more in depth about this AWS stack, we really went after a couple of them. We went after about Lambda, EventBridge, Cognito, etc. And what you're seeing here, Lambda, EventBridge, and step functions is a very interesting mix that we can do so many things with it. EventBridge is pretty recent, right? I think November was it was adopted that time. But so far this has been a great journey with stack. So Mike and Ben will provide you more information on how we're using these ones and how does that fit with our business guidelines. I'll let Ben explain about our architecture.
Great. Thank you, Quentin, for that great overview of Gamercraft. Good afternoon, everyone, and thank you all for the opportunity to present our work to you. So I'm going to start with the summary of our architecture, and then I'll move into how our tournament flow works and then some of the challenges we faced in building it. So as you can see here, we've divided our stack into several microservices, and each handles a different part of our system. One for the distribution of prizes, another for team management, and so on. So each has its own DynamDB table and its own serverless configuration, and each is deployed separately, but they also share some common resources like API Gateway and S3. So by far the most complex and unique service we had to build is the one that handles the tournament flow. And there are a few reasons why this one is the most difficult to build and test. Number one, timing is everything. So if you set a start date for a tournament, it means that the tournament needs to start at that time and everything else needs to follow sequentially. Related to this, we also had to make decisions about when to start a new match. Do we start all matches in a round simultaneously, or do we start them more ad hoc whenever the participating teams are ready? Number two, often your tournament depends on response from an external API set up by the game developers, and you need to have a plan for what happens if that API is down for some reason, or when it just doesn't exist, when you're working with a game that doesn't have an API. Number three, tournament flows can be really complex, and there are a lot of different possible corner cases and paths that can happen, and we need to make sure we handle every possible situation. So to help us conquer these challenges, we focused on building up a minimum viable product based on a few assumptions. Number one, we assumed that our tournaments are League of Legends tournaments. League of Legends is an enormously popular game. So we were able to amass a lot of beta users very quickly. But more importantly, the developer of League, Riot Games, has a great API that abstracts away a lot of the difficulties of running these tournaments. Number two, there are a lot of different ways to run a tournament. You could have a Swiss-style tournament. We decided to focus on just single elimination tournaments. So a very straightforward single elimination bracket. And similarly, there are a lot of different ways to distribute distribute prizes to users, but we decided to assume that we're going to give only prizes out to the top end users at first, and they would decrease as you go down the rankings. So once we made those assumptions, our next step was to build this flow diagram that we're showing you right now. Our architecture is event-driven, so each of the orange nodes is a Lambda, and they're connected by pink events. So by creating this flow diagram, we're able to communicate more effectively about how the tournament flow works, and also identify any possible problems or situations that might come up in a tournament that we might have overlooked at first. So this is a little hard to read. So here's a simplified diagram. So as you can see, first an admin creates a tournament with a set start time. Once that time is reached, a bracket is generated and teams are sent off to their first matches. So we have checks on a timer, and those are in place to make sure that teams are in the lobby within a certain time, and if not, those teams are forfeited. When the match results come back from the tournament API, the results are recorded and the winning team advances to the next match, which starts when both teams are ready. And then finally, the tournament ends when all the matches are completed, and we distribute prizes accordingly. So none of this would be possible without using AWS step functions, which have really helped us out. As you may know, these kind of act as a state machine, so you can run several lambdas in sequence, and they're really useful for carrying out a predefined sequence of steps, especially at a set start time. So we have two step functions that are key to our tournament flow are the ones to start a tournament that goes all the way from the initial tournament creation to the tournament start date. It triggers all these lambdas for generating brackets and so on. The other is for checking that players are ready and ready to go in their game lobbies. So when a match starts, we set up a timer. So 15 minutes later or so, we check in the lobby, make sure both teams are there, and carry out whatever actions we need to accordingly. So we built out this MVP. We finally arrived, and we've had it for a few months, and we're receiving great feedback from users. Our next challenge is to peel back some of these assumptions that we made and make our platform work under more general conditions. So we have to solve problems like decoupling from the Riot Games API. There are a lot of different games we want to support. We want to reach a wide variety of users, so we need to make sure we have a plan for what should we do when the game that we're using doesn't have an API at all. Another thing we have to do is decouple from single elimination tournament structure. There are a lot of different, as we started to receive feedback from users, we've started to identify some other kinds of tournament flows that they want. Maybe they want tournament leagues. That's all going to be easier once we kind of abstract the tournament structure away from how our matches flow into one another. Finally, we have also received great feedback from users with regard to prizes, and we want to be able to react to users' needs on this very quickly. So being able to set up a less rigid prize structure is also a priority. Thank you again. Now I'm going to hand it off to Mike, who will describe in more detail how we achieved all this from a technical standpoint.
Great. So thank you, Ben, and thank you to everybody listening right now. I'm going to talk a little bit about the tools that we use to continue to build on the speed increase that serverless provides us, because we can only really move as fast as our slowest tool in the toolkit. So the first tool that I'm going to start with is Retool. So Retool is a configuration platform for us to create admin dashboards that empower our customer success team. So we're able to build really rapidly some CRUD dashboards, different tables, without any of the overhead of the design that we have for the normal application lifecycle. The other big reason that we went with Retool is because of its strong integration with AWS services. So we can actually directly invoke our named lambdas as well as query DynamoDB directly, taking away the need for any sort of messy boilerplate or any additional services like API Gateway to perform really simple things like table scans to populate data in the dashboard. So moving on to our next tool in Toolkit, that's going to be DynamoDB Toolbar. People might be familiar with it. It's authored by Jeremy Daly. It's a really great library that enhances the document client that's provided by the AWS SDK. So some of the upsides of using this library, it's really helpful for managing our entities that we use in our relationships between all the different things that make up our different services. It also simplifies all of our queries. It really helps with mapping those entities and creating attribute aliases for us. So we're able to have developers that can work with very easy to use naming structures that make sense in the architecture, while storing the data with much smaller attributes to cut down on our size in the database. We can also really generate computed properties like compound keys, so that we don't have to worry about the overhead or any of the safety of losing those properties to just that single key. We're able to store them as well as map them directly to the computed properties just by using this toolbox. Sorry, I might have lost it. The downside is that stopped it when it was in alpha. Now it's base, so we've seen a little bit of negative effect from this. We've seen the API change a bit. We've also seen some of our aliases have changed, so that without a lot of visibility and things like that. There's also no native support
Michael,
for
you.
Can the
Move the screen.
still able to hear me?
Can you hear me?
Yes, I lost the presentation on a bit ago. Still able to see it on YouTube.
Do you see the presentation? No?
Unfortunately, I am still missing.
No. Okay, so quickly fix it. Do you see my screen?
Not yet.
Nope. No. Still not my screen? You're not seeing my screen?
Oh,
I am not.
Jérôme, you don't see it?
no.
Okay. Mike, do you have a presentation? Or
So I don't see it on YouTube or on Skype any longer. I have the one that you sent me. Not sure if that will
okay. Is it
actually resolve the issues.
okay? Try sharing your presentation. That's right.
Okay. Let me open it quickly. Okay, I'm going to attempt to share it. You able to see it?
Nope.
Okay, it's back.
Is that Quentin's screen or my own? Looks like it's Quentin's.
Okay, I think we're back.
Okay, I'm watching the current YouTube stream. I'm still seeing the Skype background.
Not on YouTube.
Should you try joining and leaving the call? Leaving and joining the call?
Maybe I need to refresh YouTube. I'm sorry. I think it's okay now. Michael, if you want to.
Yeah, I see it on YouTube, but I do not see it in Skype now. I can go based off the YouTube one, though, as long as Quentin can still move the slides. Quentin, can you give a quick check? See the mouse moving. All right. Quentin, are you there? Able to share?
I'm here. Yeah.
Are you able to share the screen in the Skype?
Yeah. It is showing in the
You can see
Skype.
your screen.
Okay. I'll have to go based off the YouTube one, unfortunately. I don't see it in Skype, but that should be all right. Okay, so sorry about that technical difficulty, guys. Apparently there's a little bit of a sound issue too, so I will just maybe start at the top of this slide to reiterate some of the stuff I've already talked about with this slide. So again, one of the tools that we're using is DynamDB Toolbox. It's a great library that enhances the document client that comes with the AWS SDK. It's really great for managing the different entities and the relationships between those entities. It simplifies our queries by allowing us to alias our different types and map our entities back when we query them. So there's a lot less overhead with that aspect of using it. We can also generate computed properties without having any of the overhead of keeping those functions anywhere outside of the actual entity creation step or update or getting steps, as well as the safety that we won't lose visibility to those properties that made up the compound properties later on. It does come with some downsides though, and that was that when we first adopted it, it was still in alpha. Now it is only in beta. We've seen the API footprint change a bit, even while we've been using it, to the point where entities, default entity names have also changed, which required us to make some changes inside of our database. It also has no native support for transactions, which we're hoping to begin utilizing. That can still be achieved because the library actually gives you low-level support to create the original request information that you can then patch into a standard transaction, but there is no magic transaction function call or any condition check transaction piece built in. The other downside that it has is that it subtly encourages making requests on a per entity basis because of that ability to very map them easily, which is a little bit in contrast to the typical single table design where you might be querying multiple terms of entities at once, but it doesn't enforce it. It's strictly just a convenience. And it also has no TypeScript support, which we are using TypeScript, so it's a bit of a bummer that it doesn't have that. So moving on to one of the last pieces of the toolkit that I'm going to talk about will be Thundra. Quentin, are you able to progress?
There is some lag between YouTube and this, but
yeah, I'm not able to see, unfortunately. Give it a quick second. I can view it on my own.
Yeah, it is up.
Okay, great. Sorry about that. Thundra. So Thundra is an extension on your typical CloudWatch logs. So we've been leveraging its logging capabilities in a few ways so far. One of the biggest ways that I've seen that we use it is for monitoring our third-party integrations, as it gives us a really, really great timeline of every request that's sent to our APIs, along with the request and response error payloads that are returned, all for free. We don't have to set up any boilerplate. It's just right out of the box. We get that entire timeline, all that data that goes in and out. We see all of it without telling it to explicitly log anything. It also provides us with cost estimations and the error rate of all of our lambdas, which right now is only so helpful in our infancy here, as we really spend pennies, but we'll probably see that increase in use as we continue to move on. So I'm actually going to jump into one of the use cases now that we use Thundra for, which is for one of our third-party APIs, Discord, which we use quite extensively, as it's something that our gamer base utilizes already to talk to, and we're not really trying to reinvent the wheel here. We're trying to be a tournament platform. We are not a text, voice, and streaming service, so we're able to utilize their toolkit, their robust API to manage a distributed bot, as well as our own pool of channels and the different roles that are associated with making sure that the right people get the right information. With this Discord integration, we're able to quickly kind of ping our users with additional information driven off of this event, off the events that we already have as part of our different services, namely the tournament service, for things like when a match is about to start, what the match code is. It's really helpful, and we don't need to add any additional UI. We also have that as a place where we gather feedback from our beta testers and have that all get aggregated to different locations, all just through their API and through our serverless architecture. But with that, and as I said, when we utilize Lambda to start troubleshooting this, we have had some issues with integrating with third-party APIs, and that's particularly with rate limiting. So without a persistent server, I just saw the slide change. Can you move it back? Sorry. Current issue we face with that rate limiting. Without a persistent server, we really lose the ability to easily handle the concurrency, the frequency of our requests. We're still actively solving this issue, but right now one of the workable solutions we found is using state functions. So we're actually able to break down every single API request into its own Lambda that runs on its own, waiting for multiple requests that fire off in parallel to resolve using those step functions, and we're able to set concurrency limits and retry frequencies to those particular functions that we know are going to be rate limited. So we're able to protect ourselves from those rate limits to a better level than we could before, without really needing to persist any state between our different executions. So now I'm going to talk lastly about a little bit of our DevOps. So some of the current advantages that we've seen so far of using a serverless model are that we can easily spin up new cloud formation stacks for our new devs. We can also quickly populate those stacks and databases with oh, I can see the slides on our side now too. Wonderful. Okay. Are we good to go? Seems like it.
Yeah.
Yes.
Great. Sorry again, guys. I'm not sure where we cut out, so I will. It's a very quick slide. I'll start from the top here. For a brand new team, choosing serverless was absolutely the way to go. It helps us to build much more rapidly than I think we could with any other architecture. We're able to much better navigate our complicated event-driven tournament architecture with the module approach that serverless really enforces, where we have to separate those concerns. DynamDB has fit really seamlessly into our architecture, and while we're really only scratching the surface now, we have some really big plans to deliver a fast and reliable experience to our customers that couldn't be accomplished with really any other managed database. And the toolkit and ecosystem around serverless is just constantly growing around us, and it leaves us way more time to focus on delivering content rather than on our architecture and infrastructure. So with that, I'm going to hand it back to Quinn.
Yes, thank you very much, Mike, Ben. So yeah, that's pretty much it. We were very excited about. We will be launching the app on December, January, in a few months. We are going to expand our team, and serverless will be obviously one of our key choices into making that happen. So yeah, if you have any question, let us know. Thank you very much.
Thank you, guys. I think we have a few questions, actually, from Gwenel. The first one was, what was the technical challenges you had building this architecture?
Do we want to use, for example, the Discord microservice, Mike, Ben, on the challenges we faced on this one?
Yeah, I can speak to that one.
Yeah, go ahead.
Yeah, so one of the things that we've been working on and are still working on, actually on my to-do list today, is improving the rate limiting issue with Discord. Rate limiting is kind of one of the biggest problems that we've had so far from the third party guys, them not being existent and trying to have some rollback on how to handle those, because we don't have any persistent state, and we don't know, when we get a response from Discord, the header is actually incorporated the rate limit bucket, what's being rate limited, and how long we have. So we could send off 1,000 of those requests at once, and only one of them will really tell us what our next information, what our next step to take is. But they all already executed, so we have to have plans for that. The traditional server might queue them up very, very conveniently. We explored different options. We looked into SQS to try to queue them up and having a DL queue for handling the failures. But that still didn't really solve the problem, because we didn't have another way to then regulate the rate. If you try to use Lambda with SQS, it has a default pull rate that you can't really configure. And if you set it up to pull using like a CloudWatch rule, you still run into maybe not running frequently enough, and all that. You still can't reduce down those results into something that is then usable by the next step, which is to send a message to the users that have now been granted this role from this thing that's being rate limited. So that was a challenge, and we're still exploring new options. So we started looking into architecture that are already incorporating our app, namely step functions, as I kind of stated. And because of how they've expanded just in this short amount of time that they've really come to their prime, you can execute multiple parallel requests and reduce down those results. So we're seeing that as a much more workable solution, but it still doesn't solve the problem of you could still have 10,000 requests all hit at one single time, and even though the retry could take maybe a second between, you still have that initial hit that could cause problems on the Discord rate limit side, and it also doesn't solve the problem of being able to dynamically change the time. We can't guarantee that Discord won't change their rate limits. So rate limiting is definitely one of the challenges we've faced so far from our third-party APIs.
Yeah, a very good explanation. Yeah, perfect. Any other questions, Jérôme?
Thank you. Thank you. Another one from Gren again. So, do you think you had some overhead in terms of developing cost compared to a more classical architecture?
I can start on that, and if Ben might have anything they can add up. The estimating cost for the root cause of a serverless architecture is always very tricky. And it's about, we will save time, we will save money. It's basically the main issue. What we didn't do yet a deep dive into our cost analysis because we didn't need to yet. We're still on the startup, the money, the credits given by AWS. So yeah, but my guess is the Lambda won't actually be the highest. Might not be one of the highest part of it. Managing, the Cognito may be actually one of the most important costs. Ben, Mike, do you have anything to add on our potential overhead cost?
Are we talking about monetary, like billing from AWS specifically,
or actually, yeah,
or is it more general development costs? I don't really have any insight on the billing, because I don't look at that, but I think that. I think, and this ties into another question that I'm seeing, which is, did you have any difficulties going from standard architecture to serverless? I think by using a serverless architecture, it forces you into some good development practices that you want to have in other architectures anyway. You want to have good abstraction barriers. You want to keep your code organized by functionality, and using a serverless architecture really just the nature of it makes you do those things already. And so I think that's a definite benefit, and it helps keep down costs related to redoing stuff because it was done poorly the first time.
Okay. Yep. Great answer. Well, any other questions, Jérôme?
Not there.
Okay, perfect.
Any other question? No?
Nope.
Okay.
Yep.
So thank you guys. Thank you very much. Sorry for the glitch. I really need to find a better solution to stream everything. Just a word about the next time. Let me just share something. Where is? Okay. So thank you, Quentin, Michael, and Ben. Thank you all. Thanks for your patience. Just before you leave, I'm happy to announce the next meetup event. So it will be the 3rd of November, and we'll have Slobodan Stovanovic. If you don't know him, he's a co-author of the book Serverless Application with Node.js, and he's a serverless hero, AWS serverless hero. And he will talk about testing serverless application, which can be a challenge and how it can help to avoid vendor locking. So I'm really looking forward to this event and to see you again. And in the meantime, take care. And good evening, everyone.
Thank you.
Thank you, everyone. Bye.
Bye-bye.